When ChatGPT was introduced in late 2022, it sent shockwaves through the tech industry and beyond. Within just 2 months, it attracted over 100 million users, one of the fastest adoptions of any technology ever. Suddenly, everyone was talking to an AI as if it were a person, getting it to write stories, answer questions, even crack jokes. What made this possible? The magic behind these AI chatbots is something called a large language model, or LLM. In this video, we'll dive into what LLMs are, how they learn to talk, what they can do, why bias and responsible use matter, the different flavors of LLMs out there, and where all this is heading. Imagine trying to teach a child every language trick in the book by having them read the entire internet. That's roughly how an LLM learns.
In simple terms, a large language model is a massive neural network that has been fed an enormous amount of text.
These models aren't programmed with explicit rules. Instead, they learn from examples.
Specifically, an LLM is trained to predict the next word in a sentence over and over again on billions of sentences. It's like a super advanced autocomplete. Given a prompt, it tries to guess what comes next. During training, the model sees a sentence like "the cat sat on the" and learns that "mat" is a likely completion. By doing this prediction game trillions of times, the model gradually adjusts millions or even billions of internal settings to get better at guessing. Some of today's models have hundreds of billions of these parameters. For example, OpenAI's GPT-3 has about 175 billion, effectively making them incredibly complex learners. To achieve this, LLMs consume vast amounts of data. They read everything from books, research papers, and Wikipedia articles to open web pages and social media posts. In fact, many models are trained on datasets like the Common Crawl, which contains a snapshot of the web with over 50 billion pages, as well as the entire Wikipedia. You can imagine an AI reading literally millions of books and web pages, ingesting knowledge about history, science, pop culture, you name it. Training a model on this mountain of text takes enormous computing power. Think of warehouses of supercomputers churning for weeks or months. By the end, the LLM has statistically learned which words and phrases tend to follow each other. It doesn't memorize complete passages. Instead, it learns the patterns of language. The result is an AI model that can generate sentences, paragraphs, even full essays that sound remarkably human. Once trained, a large language model is like a multi-talented wordsmith. It can take an input prompt and generate new text that continues or responds to that prompt. This enables a single LLM to perform many different tasks that previously needed separate specialized programs. For example, one model can answer questions, summarize documents, translate between languages, write stories or articles, and even carry on a conversation in a chat-like manner.
This flexibility is one reason LLMs have been so disruptive. They can handle writing and language tasks that range from creative to technical.
Want a poem about coffee in the style of Shakespeare?
An LLM can do that.
Need a 3-sentence summary of a 100-page report?
It can do that too.
In fact, large language models are even being used to write computer code, draft emails and reports, help with homework problems, and more. They have learned enough patterns that they can simulate logic and reasoning on the fly.
One striking capability of advanced LLMs is their knack for few-shot learning.
They can learn from just a few examples in a prompt.
For instance, if you show an LLM 1 or 2 example math problems and solutions, it can often figure out how to solve a new similar problem. They can also juggle a lot of information at once.
Some modern models can accept very large prompts.
For example, Claude 2 can intake up to 100k tokens of text. That's like feeding it an entire book in one go, and it can analyze or summarize it. These models are also increasingly multilingual. One commercial model was reported to work in over 100 different languages,
meaning it can communicate and translate between languages from English to Spanish to Hindi to Swahili. And they are not just parroting memorized phrases. LLMs generate new sentences word by word, so they can adapt to unusual questions or creative requests.
Perhaps most impressively, top-tier LLMs have started to match or exceed human performance on certain exams and benchmarks.
A famous example is GPT-4, which in early evaluations passed the uniform bar exam with a score in approximately the top 10% of test takers. Think about that. An AI model, having read lots of legal text during training, can produce answers on a law exam good enough to rival attorneys. Similarly, LLMs have scored well on SATs, coding competitions, and other tests of knowledge and reasoning. Now, to be clear, this doesn't mean the AI truly understands law or math or medicine the way a human does, but it knows the patterns of these domains well enough to produce high-scoring answers. It's like having a very well-read parrot that can remix its knowledge to tackle new questions. This has enormous practical potential, from assisting doctors
by summarizing medical literature, to helping programmers by suggesting code, to enabling customer service bots that actually understand your questions.
It's why many people say we're in a generative AI boom with LLMs at its core.
Like any powerful tool, LLMs come with challenges and risks.
One big issue is bias.
Because these models learn from real-world data, they inevitably pick up the biases, stereotypes, and imbalances present in society.
If much of the training text portrays a certain group of people in a negative or limited way, the model can subconsciously reflect that in its outputs. For example, if it's seen fewer examples of women in STEM roles in its training data, it might unknowingly produce text that reinforces that gender stereotype. Bias can be about gender, race, religion, and more, and it's built into the process of training on broad internet data.
This means developers have to work actively to detect and mitigate these biases.
Responsible AI teams will curate training data, filter out toxic content, and fine-tune models with an eye toward fairness.
They also set up guidelines for the AI's behavior.
In fact, many modern LLMs undergo an additional training step where human reviewers give feedback, teaching the model to avoid or correct prejudiced and harmful outputs.
The goal is to have the AI be helpful and respectful to everyone rather than amplifying societal biases. This is an ongoing challenge in AI research. We want LLMs to mirror the best of humanity's knowledge, not the worst.
Large language models also have a tendency to hallucinate, not in the psychedelic sense, but in that they sometimes just make stuff up.
An LLM might confidently state a complete falsehood as if it were fact.
In technical terms, LLM hallucination is AI-generated false, misleading, or nonsensical information presented as fact. This happens because the model is always guessing the next word that sounds right, not cross-checking a database for truth. If the training data had inconsistent or sparse information on a topic, the AI may fill the gaps with a plausible-sounding invention. For example, a travel chatbot might advise you about a non-existent airline policy or a fake fee that it just stitched together from patterns it saw. In one real incident, an airline's customer service bot cited a refund policy that didn't actually exist, causing quite a bit of confusion until humans stepped in. Needless to say, trusting in LLM's every word can be risky.
Responsible use of LLMs means double-checking critical information and building systems to curb these hallucinations.
AI developers employ various strategies. Some use retrieval techniques, others put the AI through fact-checkers, and almost all include a human in the loop for high-stakes uses. Moreover, companies like OpenAI and Anthropic have baked-in guidelines for the AI. For example, Anthropic's Claude model is designed with a constitution of principles to keep its responses helpful, honest, and harmless.
OpenAI uses techniques like reinforcement learning from human feedback to make models like ChatGPT more truthful and less toxic by training them on human-preferred responses. All these efforts fall under responsible AI, making sure that as we unleash these powerful models, we do so in a way that minimizes harm, avoids unfair biases, and prevents misuse. It's a tough balance, essentially teaching a free-form generation machine to know its limits.
As a user, it's always good to remember that an LLM might be very convincing, but still wrong, so a healthy dose of skepticism and verification is your friend.
Not all LLMs are identical. In fact, there's a whole menagerie of models, each with different designs and intended uses.
The term LLM really just means a large language model, but under the hood there are variations.
For instance, BERT is an LLM developed by Google that isn't a chatbot at all. It's used to understand language rather than generate it. BERT helped Google search better understand the intent behind your queries. On the other hand, GPT-3/GPT-4 or Claude are designed with generation and conversation in mind. They produce new text and are often used in chatbots or writing assistants. Some models are specialized. There are LLMs fine-tuned specifically for coding help, for medical advice, or for other niches.
These specialized models take a general LLM and further train it on domain-specific data.
For example, you might have an LLM that's a whiz answering legal questions because it was fed thousands of law documents.
Another key difference is who builds and controls the model.
Many of the most famous LLMs come from big tech companies, OpenAI's GPT series, Google's Parallel, Meta's Llama, and so on. OpenAI's ChatGPT got the spotlight, but soon after many competing models have been released. Some belong to big companies like Google, Amazon, and Microsoft. Others are open source. Open source LLMs are models whose code and sometimes training data are openly available for anyone to use or modify. An example is Meta's Llama, which was released for research and spawned many community adaptations. Open source models might be smaller or slightly less polished than the ultra-large corporate ones, but they offer more transparency and can be tailored to specific needs by the community.
In contrast, proprietary models are typically larger and more powerful, but operate like black boxes. We interact with them via an API or interface, but the details are hidden. Each approach has its place. If a company needs an AI to handle its customer service chats, but with custom company data, they might fine-tune an open-source LLM for that purpose. If a writer just wants a creative assistant, they might use a powerful off-the-shelf model via an app.
LLMs also vary in size and capabilities.
Some run on a regular laptop or phone. These smaller models might have a few 100 million parameters and can do basic tasks. Others, the true giants, have tens or hundreds of billions of parameters and require an entire server farm to run. Interestingly, bigger isn't always better for every task, but generally, the largest models show the most fluent and general abilities. There's also innovation in making models more efficient, so that smaller models behave like bigger ones through clever training techniques. Another frontier is multimodal models, AI that doesn't just handle text. For example, Google's Gemini is multimodal, meaning it can take in images or other inputs along with text. You could give such a model a photo and ask questions about it and ask it to write a caption.
This opens up whole new use cases, from analyzing diagrams to controlling robots with natural language.
Different models might also have different personalities or styles depending on how they were tuned. The key point is LLMs are not one size fits all. When someone says AI, it could mean a lot of different systems under the hood, each designed a bit differently for different goals. Large language models have rapidly gone from a research curiosity to a household topic, and by now you hopefully have a clearer picture of what they are. We've seen that an LLM is essentially a predictive text engine supercharged by huge scale. It's read basically the entire internet and uses that experience to chat with you, answer your questions, or produce whatever text you ask for. They are incredibly impressive in their fluency and versatility, yet they come with important caveats around accuracy and bias. Even the creators of these models don't fully understand everything that goes on inside that giant neural network. There's a bit of mystery in how exactly they organize all that knowledge. What we do know is that these models don't think or feel the way humans do. They're pattern recognizers and generators. But when guided correctly, they can be astonishingly useful tools.
The future of LLMs is an exciting mix of promise and responsibility.
On one hand, we can expect even more capable models, ones that might handle multiple types of media, work with more up-to-date information, or integrate better with our day-to-day software. Imagine AI tutors, AI doctors' assistants, AI creative partners, all powered by LLM cores that keep improving. On the other hand, there's a lot of work to ensure this is good for society. That means continuing to reduce biases, prevent malicious uses, and making sure people are educated about the strengths and limits of these tools. As one AI ethics motto puts it, with great power comes great responsibility. Ultimately, large language models are a step toward AI that can interact with us on our terms through language, the way we humans communicate. They are bridges between human ideas and machine processing. Understanding how they work under the hood helps demystify the magic. It shows us that behind the seemingly genius responses is a lot of math, data, and probability, not a sentient mind. By knowing this, we can both appreciate the technology and use it wisely. So the next time you're chatting with an AI or reading something it wrote, you'll know a bit about the complex dance of algorithms and data that makes that possible.
And as AI continues to evolve, staying informed will help all of us ensure it's developed and used in a way that truly benefits everyone.